Hey everyone, welcome to another mathematical challenge question. Let's have a read of it together. So P, Q, R and S are two-digit primes, which between them use all the non-zero digits except 5. What was the value of P plus Q plus R plus S? Okay, interesting question. So have a go at it yourself, have a pause of the video, then afterwards we'll try and solve it together. Okay, so the key thing is that these two-digit primes use all the non-zero digits except from 5. So what are those? So those are 1, 2, 3, 4, skip 5, 6, 7, 8, and 9. So my 4 numbers will include 2 of these. So for example, 13 is a two-digit prime, and then 29 is a two-digit prime, and so on. So we need to think carefully. What can two-digit primes end in? What can their final digit be? Well, it can't be an even number because then that number will be divisible by 2 and therefore not a prime number. So we know that it can't end in 2, 4, 6 or 8. So it must end in 1, 3, 7 and 9. Cool. Now we just need to work out which numbers go in front of these. So let's cross off 1, 3, 7 and 9 since we've used them. Now we just need to put in front 2, 4, 6 and 8 in front of these numbers to create prime numbers. Okay. What can I put in front of the 9? I know I can't put 6 in front of the 9 because then that number will be divisible by 3. Can I put 2 in front? Yes. Can I put 4 in front? No, because that's 7 squared. Can I put 8 in front? Yes, I can. So let's just put, as a placeholder, 2 and 8 as possible contenders for what can be in front of the 9. Now let's have a look at the others. What can I put in front of the 7? If we had 27, that's divisible by 3. 47 is a prime number, so we can have 4. 67, is that a prime number? Yes, it is. So we could also have a 6 there. And then 87 we can't have because that is divisible by 3. Okay, let's have a look at what can go in front of the 3. Can we have 23? Yes, because that's a prime number. Can we have 43? Yes, that is another prime number. Can we have 63? No, because that's divisible by 3. And 83, that is also a prime number. Then finally, we have 1. Can we have 21? No, that's divisible by 3. Can we have 41? Yes, that is a prime number. Can we have 61? Yes, that's another prime number. And then 81 is divisible by 3 and 9, so we can't have 8. Okay, cool. So I can see that I could have 89 here and 23 here. Then I could have 41 here and 67 here. Cool. What happens when I add up all of these prime numbers? Let's add the unit column first. I get 3 plus 7, 10, plus another 10, which is 20. So I write as 0 and I carry the 2 forward. Now let's add these numbers together. 8 plus 2 is 10, add another 10 is 20, carry the 2 over is 22. So the answer is 220. But I think I've just spotted an easier method. We actually didn't need to know what all the prime numbers could be. We just needed to know what was in the units column and what was in the tens column. We know that in the units column, we have 1, 3, 7, and 9. And in the tens column, we know that we have some ordering of 2, 4, 6, and 8. So we would get the same calculation for our sum, even though we didn't need to know what our prime numbers actually were. So that would have been a quicker method for us. Cool. If you enjoyed the video, check out some of my other ones. Bye bye.